Let's look at how we can divide these polynomials using long division. So first I'm going to write the divisor, the 2x minus 1, out in front, and write my dividend, my 2x cubed plus x squared plus 5x minus 1 underneath. So as we're making our way through the long division process, the process will always follow the steps of divide, multiply, subtract, and then bring down. When we're thinking about the division step, we're going to use just the leading terms from each polynomial. So I'm going to divide 2x cubed by just the 2x. If it helps to do this as scratch work off to the side, you can definitely write out these steps. So as we're dividing, the 2's are going to cancel. X cubed divided by x gives us an x squared. So I'm going to write that up on top. That's going to be the first term of our quotient. So after we divide, now we need to multiply. Take the x squared that you just wrote up on top times the entire divisor out in front. So we're going to take the x squared times the 2x and the x squared times the minus 1. The values that we get from that product we're going to write underneath our dividend. So x squared times 2x is 2x cubed. X squared times a minus 1 gives us a minus x squared. And now we're going to subtract. 2x cubed minus 2x cubed, those terms cancel. Be really careful on this subtraction step here. We're taking a 1x squared minus a negative 1x squared. So 1 minus a negative 1 is like 1 plus 1. So this becomes 2x squared. And then bring down the plus 5x. So now we want to essentially start the process again. We're back to the division step. So we're going to take this 2x squared and divide by this 2x. So 2x squared divided by 2x, in this case the 2's cancel again, and x squared divided by x is just x. So I'm going to write that up on top, and after I divide, I multiply x times 2x minus 1. So x times 2x is 2x squared. X times a minus 1 gives us minus 1x. So divide, multiply, subtract. 2x squared minus 2x squared, those terms cancel. And again, watch the subtraction here. 5 minus a negative 1 is like 5 plus 1. So that's going to give us 6x. And then bring down one more time the minus 1. So we're back to the beginning of the process, back to divide. Take the leading term on the inside and divide by the leading term on the outside. So we're thinking about 6x divided by 2x. 6 divided by 2 is 3. The x's cancel this time. I'm going to put a plus 3 up on top. So 3 times 2x minus 1 gives us 6x. 3 times a negative 1 gives us minus 3. 6x minus 6x cancels. Think carefully here. Negative 1 minus a negative 3. So you can think of that as like negative 1 plus 3, which is going to give us a positive 2. So the part that came out up on top, this is called our quotient. The part that came out down here at the bottom is called the remainder. So if we were to write our answer, we can write it as quotient x squared plus x plus 3 plus the remainder 2 over 2x minus 1. So that's how we could divide those polynomials using long division. Now let's think about this same problem again, only this time let's think about, could we do this using synthetic division? So when we introduced synthetic division, we said that the thing doing the dividing, the divisor, needs to be a degree 1 polynomial, x to the first, which this one is, but we also said that the coefficient needs to be a 1. So in this case, in the given divisor, the leading coefficient is 2. But we could do a little bit of rewriting. So since I need that leading coefficient to be a 1 to be able to do synthetic division, I could do some rewriting to get it into this form. So if I were to factor out that leading coefficient of 2, since I need that to be gone. From each term, if I divide out a 2, so from 2x, if I divide out a 2, it leaves an x. From the minus 1, if I divide out a 2, it becomes minus 1/2. So notice if you multiplied that back out, 2 times x would give you your 2x. 2 times 1/2 would give you back your minus 1. Because I divided out a 2 of all of my terms on the bottom, I'm also going to divide out a 2 from all of the terms on top. So if I factor out or divide each one of those terms by 2, 2x cubed divided by 2 gives us x cubed. 1x squared divided by 2 becomes 1/2 x squared. 5x divided by 2 becomes 5/2 x. Minus 1 divided by 2 becomes a minus 1/2. So essentially what we're saying is you could cancel those 2's, and this would be an equivalent division to the original problem that we were given. The reason that we rewrote it this way is so that we can do synthetic division. So if we were doing synthetic division, now out in front, since it's an x minus 1/2, would be a 1/2. Underneath would be 1, 1/2, 5/2, and minus 1/2. So if I bring down the 1, 1/2 times 1 is 1/2. Adding 1/2 plus 1/2 is 2/2, or 1. 1/2 times 1 is 1/2. Adding 5/2 plus 1/2 is 6/2, or we could turn that 6/2 into 3. 1/2 times 3 is 3/2. And adding negative 1/2 plus 3/2 is 2/2, but then we could turn that 2/2 into 1. So this is the remainder that we came up with. And these are the coefficients for our quotient. So if we were to write that out in the format that we usually write our answers for these, so the 3 would be a constant, the 1 would be an x, the other one would be an x squared. So we have x squared plus x plus 3. That should sound familiar. But then we have a remainder of 1, but be careful, the thing that was doing the dividing in this one because of our simplified form was x minus 1/2. Well, if you compare that back to our answer that we had before when we did this by long division, the quotient looks exactly the same as what we had before. But right now, this remainder looks a little bit different. It turns out that we can turn this into the same format if we take just this last term. If we were to multiply the top and the bottom by 2, I'd still have my x squared plus x plus 3. But if I multiply this last fraction, top and bottom, by 2, 1 times 2 is 2, x times 2 is 2, 1/2 times is 2x, 1/2 times 2 gives us minus 1. This now looks exactly the same as the answer that we got when we used our long division. So the question was, can we do synthetic division if the leading coefficient is not 1? So as long as it's a degree 1, the exponent is 1, we can do it, but it gets a little bit messy with the fractions. And so we need to divide out that leading coefficient from every single term in the denominator and the numerator, perform our synthetic division, and then be careful with the remainder that we've actually changed the divisor. So to make it look the same as what we would have had with our long division, we may need to do a little bit of rewriting of our remainder at the end. So it is possible, but just a little bit messy.